Hi, calculus student. This video is for chapter 3.6, part 2, chain rule, the second part of chain rule. So earlier we introduced general power rule. That means if you can write g of x inside, the inside function as a power, then the derivative of that function is you apply a general power rule, dy dx. Say, for example, y equal to 3x squared minus xx plus 1 to the 5th power. You can see that this is the g of x that we talk about. This is the inside one, and we call it g of x. And the general power rule say just keep this, just treat it as g of x to the 5. So it will be 5, the same g of x, 3x squared minus 6x plus 1 to the 4, because you multiply divided by 1, you subtract 1, and then you do d dx of the inside of 3x squared minus 6x plus 1 is multiply. So you copy the first part, 3x squared minus 6x plus 1 to the 4th. And then the derivative of this would be 2 times 3, 6, x to the power 1 minus 6. And if you want to, you can factor the 6 out. It will be 30. 3x squared minus 6x plus 1 to the power 4, and then x minus 1. And this is in factorial form, and that's perfectly okay. The next example would be, we want to do a derivative. Oh, I forgot y equal, okay. Of y equal the square root of 5 minus 2x squared. Remember we say, if I have a square root of something, I really don't know how to do the derivative because we only know how to do the square root of x. But if square root of something else, then I don't know. So we will rewrite it as a power, because we want to apply the general power rule. So the inside is 5 minus 2x squared. Square root means is to the power 1/2. So we can perfectly apply the general power rule. dy dx would be, this is n, and to the inside, don't change anything, 5 minus 2x squared. To the 1/2 minus 1 is negative 1/2. Okay, so that is the general power rule. And then we have to do a d dx of the inside. Dx of 5 minus 2x squared multiplied to it. So this is a negative 1/2. We know that it's in the denominator. Just write it here as 5 minus 2x squared. Change it back into positive, into radical. And this one would be just 5 is a 0. Negative 2x squared would become negative 4x to the power 1. So write everything back would be, you can see that the 2 and the 4 can cancel. So the top would be negative 2x over square root of 5 minus 2x squared. And that's the final answer for dy dx of this particular function. The next one, so if we want to apply general power rule, we want to write an inside. Sine 4 to the x, we talk about this, is sine x to the 4th power, right? General power rule, so dy dx is 4 times, just keep sine x, but it will be 3 times, remember, times dy dx of the inside. What is it? The inside is just sine x. Okay, so we would have 4 sine x to the power 3 times cosine x, and that's the answer. This one, find the derivative of y equal to sine x plus tangent x to the power negative 3. So this is well written as, inside and a power. The power is negative 3. So use general power rule, which is a special kind of chain rule. d dx of dy dx would equal to, this is my n, and this is the g of x inside, right? So we would just pretend that it is something to the n. So n would be in the front, multiply as a coefficient, and then the inside I just copy secant x plus tangent x. And then what power would I have? It will be negative 3 minus 1 is negative 4 times dy dx or d dx of secant x plus tangent x. So let's do it. So it will be negative 3. So just, it is a 4th power. So we write as secant x plus tangent x to the fourth, because it's negative, that means it's in the denominator. And then that one would multiply as, what is the derivative of secant x? It's secant tangent. What's the derivative of tangent x? It's secant square x. Yeah, so you can rewrite it as negative 3 of these things. Both of them have secant, so you can factor the secant x out. It will be tangent x plus secant x. Over secant x plus tangent x to the power fourth. Now you see that these two are identical, right? So I can cancel one out, so this would be a 3. So the answer would be negative 3 secant x over secant plus tangent x. No, this whole factor. 3 times. So maybe I'll write the answer here. It's very small. Negative 3, so equal to negative 3, only secant x in the top over secant x plus tangent x, but 3 times. And then let's move on to the next page. So that's the general power rule. So the next things we want to talk about is chain rule on trig functions. So we say the need for these is, what if I want to do sine 2x, right? When we talk about 3.6 part 1, we say the need for doing this is, suppose I have sine 2x, I want to find derivative. How do we do it? So we'll say if my function is cosine of something or sine of something, then when I do the derivative of it, I would just do cosine become sine, negative sine of the same thing, and then do a derivative of the inside. And when I do k of x, k prime of x would equal to do the derivative of sine of something would be cosine of something, and then times the derivative of the inside g prime of x. Very similar to the general power rule. So but this strategy also applies to other trig functions, meaning if it is tangent of something, you would do the tangent of that something's derivative and then do the derivative of the inside. So let's do 2 examples. Example 1 is, I forgot y equal in all cases. I should write, get the pen. Oh, this one is really small. Let me blow it up a little bit. Okay, so we can see it now. So the outside now is 7x cubed. Okay, so the x cube is really just x cubed. Cosine is the outside, right? So I have cosine of something which is not x, but 7x cubed. So this is outside and it's cosine. This is g of x. So I should say this is y equal. So what would dy dx be? The dy dx be would just pretend that I'm doing cosine of something. What would it be? It would be sine of that something, 7x cubed. But I have to do a derivative of the inside, which is, I write it out. That's what it means. If you have a cosine, you do a negative sine of it, and then you do the derivative of it, right? So be negative sine, just copy. This is already done. The derivative of 7x cubed is power rule, 21x squared, right? Which is not the inside of sine, but it's actually outside. So I rewrite it as negative 21x squared sine of 7x cubed. Is the sine of the same thing, okay? Not multiply anything inside. What about this? I have sine of 4x squared minus x plus 2. So this is the g of x that we have, right? So we say dy dx would be, if I have a sine, the prime of it, the derivative of it would be a cosine of exactly the same thing. We don't change it. This is like the u in the chain rule. Multiply with the derivative of inside. Do the d dx of 4x squared minus x plus 2. So that ultimately would become what? 8x. I just minus x become 1 times, I just write this in the front, and then the same 4x squared minus x plus 2. So that is the derivative. So a very interesting function that we sometimes we see is tangent of sine x. That means what is the inside? What's the outside? The outside is a tangent x. The inside is a sine x. So this is my inside g of x. So we'll do it in class on how to do this. And theoretically, you can do one more layer. So you can have powers of power. So let's see what this happen. The next thing is about applying chain rule multiple times. What about, consider this, I have a function sine square, but the inside is 4x. So now what is the ultimately outside? The ultimately outside is not sine x, it's sine 4x squared, right? It's sine 4x, which is something, is a function, but I want to square it, right? So this is the utmost outside. And then inside, I also have a second layer inside and a inside, right? So this is the outside and the inside. But this is the most outside one. So you have to apply it multiple times. So apply one by one. Do that one first, which is a general power rule. So we say dy dx would equal to 2 of just sine 4x, right? Don't change anything of the inside to the power 1. Now I have to do d dx of sine 4x, right? d dx of sine 4x means this is actually a outside and this is an inside. So when I do this, so I'll just copy 2 sine 4x times, what is sine of something? Is cosine of 4x. And then I do d dx of what? 4x, which is 4. So finally we would have, so this become 4. So the answer would be 8 sine 4x cosine 4x. And that's the answer. So you can do this chain rule multiple times, but every time you just do the outside and then do the d dx of the inside. And then supposingly this would apply another chain rule and you can do that. So the same for this. I find the derivative of sine square pi x plus 1. The most outside is secant, not sine, secant pi x plus 1 square, right? So I write it as secant pi x plus 1 and then square. So the most outside is a square function. So dy dx for this particular function would be 2 secant pi x plus 1 to the power 1 time, which is just 1. And then I do a d dx of a secant thing, right? Secant of pi x plus 1. But this is also a outside and inside. So this would become 2 secant pi x minus 1 time, what is the secant of something? Is secant of something is secant tangent. Secant of pi x minus 1. No, plus 1. It's a plus 1. It is a plus 1. Don't know why it become minus 1. And then a tangent pi x plus 1. Just treat everything inside as if it is like that. And then a d dx of pi x plus 1. That is the end. The third chain. That's why it's called chain rule. You just do one at a time. So these two are the same. So maybe I'll just do 2 secant square pi x plus 1 times tangent pi x plus 1 times, what is d dx of pi x? Pi. Okay, so you can rewrite it as 2 pi secant square pi x plus 1 tangent pi x plus 1, and that's the final answer. So we'll do chain rule with product rule and quotient rule in part 3 of 3.6.